All right, in this video, we will go through how you figure out the molecular shape of a molecule based on the drawing. So make sure you have your yellow periodic table with you. To figure out the shape, there is a document kind of in the back of the yellow packet. It's called Molecular Geometry, and it's a table that looks like this. This is not all the shapes that molecules have, but these are all of the shapes that we are going to worry about. So if you have that with you, and as long as you know how to read this, you will be set. So the first column is number of atoms bonded to the central atom. So for example, in this SO2 example, sulfur is our central atom. So this molecule would have 2 atoms bonded to the central atom. So once we figure out how many atoms are bonded to the central atom, then that eliminates several of the shapes. So that one is either going to be linear or bent. And we'll go through an example of each so you can see all the different shapes. And I have a special treat, guys. I have my molecule kit that I brought in. So we're going to build molecules. It's going to be amazing. You're going to probably want to buy one. I'm sure you can get one on Amazon. Nothing says you're cool unless you have your own molecule kit. Okay. Here we go. HBr. So HBr is kind of an exception to this chart because it doesn't have a central atom. So HBr only has 2 molecules. So if you put 2 molecules side by side, what's the only shape that it can ever be? Linear. So if you only have 2 molecules, the shape is always linear. All right, the next one is SO2. Whoops. So again, the first question you ask is over here on the left, how many atoms are bonded to the central atom? So sulfur is our central atom. We have 2 atoms bonded to the central atom. So we would be in this first column up here. And then you look at the number of lone electron pairs on the central atom. So remember, a pair is 2. So this would be 1 lone pair. So we have 2 bonded atoms. We have 1 lone pair of electrons. So if we have 2 bonded atoms and 1 lone pair, the shape would be bent. So what happens is those lone pairs of electrons repel and push those other bond angles down. So if we drew this correctly, it would actually have more of a bent shape like this. So these lone pairs will adjust the bond angles. All right, the next example, SCl2. Again, the first question is, how many atoms are bonded to the central atom? So on the central atom, we have 2 atoms bonded. So we'll again be in this first row. And then we look at the number of lone pairs on the central atom. So sulfur has 2 lone pairs of electrons on the central atom. So from our chart, if we have 2 bonded pairs, 2 lone pairs, the shape will also be bent. So here are these 3 examples. We'll go through the next 3 examples. One thing that I wanted to point out with this example is when you are looking at the number of atoms bonded to the central atom, you're talking about the number of atoms, not the fact that one has a double bond and one has a single bond. That actually does not determine the shape. It's the number of atoms that are bonded to the central atom. So that's why SO2 and SCl2 would have the same shape. All right, this is a continuation of slide 29. So these are the 3 Lewis structures that we have already drawn, and now we're going to add in the molecular shape. So again, in your periodic table packet towards the back, you have this chart that says molecular geometry. These are all of the shapes that we will practice and work on. There are other shapes, however, we are only going to learn about these 5. So the first question that you need to ask yourself from the chart is, how many atoms are bonded to the central atom? So in this first example, we have oxygen bonded to oxygen. So again, if you only have 2 atoms, I'm going to build this so you can see what it looks like. that are connected to one another, even if you have a double bond, the shape can only be linear. Like whichever direction we move these, the shape can only be linear. So if you only have two atoms, you don't really have a central atom, so you can't really use this chart. But know that two atoms side by side can only be linear. All right, the next one is CF4. So carbon is our central atom. We have 4 atoms bonded to carbon. So the first question, how many atoms are bonded to the central atom, would be 4. There are no lone pairs of electrons on the central atom. So when we're looking at the shape, the only atom that we really need to look at the lone pairs of electrons is that central atom. So carbon doesn't have any extra electrons that are not bonded. So that shape would be tetrahedral. All right, so with a 3D shape, I will show you what a tetrahedral molecule would look like. So this would be a tetrahedral molecule. So you have 4 atoms bonded to the central atom, but it really kind of looks like a pyramid, or it's like a 3-dimensional tetrahedral shape. So this is what tetrahedral will look like. All right, the next example is PCl3. So again, looking at the number of atoms bonded to the central atom, we would have 3 atoms bonded to the central atom. So we will be in this 3rd row. Now we have to look to see how many lone pairs of electrons are on the central atom. So remember, 2 electrons on the central atom represents 1 pair. So this would be 1 pair, or 1 lone pair of electrons. So if we have 3 atoms bonded, 1 lone pair, our shape is going to be trigonal pyramid. So if we looked at the shape of a trigonal pyramid molecule, it would look like this. So similar to the tetrahedral, but instead of having bonded electrons up here, that's where the lone pairs of electrons are. However, those lone pairs still push these other bonds downward. So it kind of looks like a pyramid where the central atom is like the top of the pyramid, and these 3 bonded atoms would be the legs. All right, hopefully that helps.